Graphing sine and cosine, something you've probably seen before in Algebra 2, but we're going to go much further into it. Alright, so we're going to start off by looking at the sine function and its graph, cosine and its graph, what amplitude and period mean, some of the key characteristics, and the method for graphing that I like to use is sometimes referred to as graphing with key points. So that's what I'm going to show you. Okay, so if we say the sine function, what we're saying is the sine values at given angles. So if x is the angle, and most of the time I'm going to be using radians, but we'll look at degrees down here, then f of x is the sine value at that angle. So you'll see all of our special angles down here with their sine values underneath. So a couple of observations to make really quickly. We start at 0, 0. We are increasing up to 1. Then we decrease back down to 0. We keep decreasing to -1 and increase back to 0. And so you'll start kind of even just informally getting a sense of this wave that sine makes. Sine gives us the word sinusoidal, which is often used to describe graphs that make that wave shape. So here's a short animation. Watch as the blue line goes around the circle. What we're tracing out on the graph is the height of that radius as it goes around the circle. Let me show you one more time. All right, as the radius goes around, what's getting recorded is the height, or the y value, which gives us the sine. And we get this nice smooth curve going around. Cosine is really closely related to sine. If you take the cosine of, or if you take the sine of a number or an angle and find the complementary angle, 90 minus that, you're going to find the cosine value. So for example, the sine of 30 degrees equals the cosine of 90 degrees. So a couple of observations to make real quick. We start at 1, decrease to 0, decrease to -1, back up to 0, and we continue going up to 1 again. So cosine starts up here at 1. It looks very similar, except it's just off. It starts at a different point than the sine function does. Here they are next to each other. The red is sine and the green is cosine. They're exactly the same shape, and actually they're transformations of one another. Usually we consider sine the main one and cosine is the one that's been shifted, but you can think about it either way. Alright, so here's some textbook definitions for you. If you were to look in your textbook right now, this is what it would read, so let me interpret this a little bit for you. The amplitude of a sinusoid, the amplitude of a sine function, the amplitude, if we're looking at this general form of the equation, is found by taking the absolute value of a, the coefficient in front. But if we're looking at the graph, the amplitude is half the height of the wave. The period, a little bit more complicated. The period is 2 pi over the absolute value of b. The way I think about this is that the amplitude, or the period of the parent function is 2 pi. And so we're just making some adjustments, and we want to think to ourselves, okay, if my period is, 8 pi, then I've divided by a fraction to get larger. And we'll see that when we start looking at the equations a little bit more. Graphically, we'll see the period by taking a look at the length of one full cycle of the wave. Alright, so here's what it looks like. On the right, you'll see a little animation of some different transformations. So as A gets larger, the wave gets taller. As we give a B value, the wave squishes in. Then you're going to see that was a phase shift at the end. We're not going to do that until next time. And we're given, alright, the amplitude is 5. We can see that in both the graph and in the equation. The period is 2 pi divided by 2, so the period is actually just pi. And then it's going to tell you about a phase shift. That's just a horizontal shift. So if we look here, the period is one complete cycle. So if you look at this purple section from here to here, it might be hard to read that it's pi right there, and so we might even just kind of look, okay, when does the graph get back to that point? Well, it goes down, up, and boom, right there, right around pi, we hit the same point in the cycle again. Pause if you need to jot any of that down. All right, so a couple of examples for you. The amplitude of each one of these, I'm going to save the last one for a try on your own in both of these. So the amplitude of this first one is 1. The amplitude here is 1/2, and then try that one on your own. And then let's look at the period. The period here, 2 pi over 1. So the period, which is given by a capital T a lot in physics class, the period is 2 pi. This one we're going to do 2 pi divided by 1/3, which is going to give us a T value of 6 pi. And try that last one on your own. Characteristics, the domain is all real values or all real numbers. The range of the parent function goes from, that's inclusive, -1 to 1, square brackets. The sine value is symmetrical about the origin. So it's an odd function. There are no asymptotes, and the period of the parent function is 2 pi. For cosine, the domain is all real values, all real numbers. Range is again -1 to 1. Symmetric, this one is symmetric over the y-axis. This one's an even function. No asymptotes, and the period starts at 2 pi in the parent function. All right, so the key points here, we're going to look for the high points and the low point and the x-intercepts. Those happen at different points if you're looking at sine and cosine, but we're going to look for those same 5 points, graphing either one. If you kind of get this table memorized, particularly, I just usually think about the positives, and then I can just kind of extend the graph backwards to get negative values. But sine, we go 0, 1, 0, -1, 0. And then cosine starts high at 1, then goes 0, -1, 0, 1. And we're going to use these values here. I'm going to start off by marking the 2 pi point, or where the period is. And this is going to be the amplitude. Then I mark a halfway point, and then I mark a quarter point and a quarter point. And then I have the skeleton for my graph, and then I can just trace it in. So find the amplitude, find the period, divide the period in half, then in quarters. For the sine, we're going to start at the origin. And for cosine, that should say for cosine, we're going to start at A. All right, so for this one, amplitude, sorry, I'm all over the place today. For amplitude, we have amplitude of 2. The period is 2 pi divided by 1/2, so we get 4 pi. Oh, I started using T. Well, period, P for period there. All right, so since it's sine, there's no scale on here, so I get to set where 2 pi is. And then I'm going to mark off pi, and then sometimes your graph starts getting pretty squished, so I don't even usually label what those tick marks are. And then I'm going to mark off my amplitude, positive and negative. And then I start doing my key points here. I have these 3 are my x-intercepts. I have a high point, I have a low point, and there's the sine graph. And let's change this one to cosine. I probably meant to do that and just didn't. Alright, so our amplitude here is 1/3, but our period, 2 pi divided by 4, is actually 1/2 pi, or pi over 2. So this is going to be a good illustration of my method and the way that I don't I totally accept you doing it in class as well. I'm going to mark off the same distance away, but I'm changing my scale. I'm going to call that pi over 2 now. So that makes this point pi over 4. Then I have these points here. This would be pi over 8. This would be 3 pi over 8. And if we're going to do cosine, here's my high and low points. Cosine starts off at the high point. And then these 2 points are going to be the zeros. We have a low point right in the middle, and we end up where we started. I'm never as good at drawing cosine, but there it is. And we could always draw it backwards to continue the graph going in the other direction. So there you have it. Try a couple. Just do those quick try on your own. And you're going to try some graphing on your own in class as well. So make sure you keep the video up if you need to review the 5 points, the key points method. Sorry this video is a little long, just a lot to get through.